Dear learner, I welcome you all to the program Postgraduate Certificate in Industrial Safety. I am Dr. Sanjay Agrawal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. And I am also Program Coordinator of this program. Dear learner, in previous session we discussed function of transformer, miniature circuit breaker, its function and what safety precaution must be taken when we are working on transformer and MCB. In this particular session we are going to discuss safety tips when you are working on generator, motor, capacitor bank and test instrument. Then we will discuss electrical shock and their effect. So first of all we are going to discuss about the capacitor bank. So as name is indicating, capacitor bank means combination of different capacitor or group of capacitor. So a capacitor bank is a group of several capacitor of the same rating that are connected in series or parallel with each other to store electrical energy as shown in figure. The resulting bank is then used to counteract or correct a power factor lag or phase shift in an alternating power supply. Now we have to discuss the safety precautions when you are using the capacitor bank. So safety precautions that should take care while testing capacitor bank are as follows. So one by one we will discuss what safety precautions are required when you are working on the capacitor bank. So first point is, while entering capacitor bank case, ensure that it is a fully discharged. Second point is, do not reclose capacitor bank breaker immediately after the tripping. Third point is, ensure discharge timer in the protection circuit for the capacitor bank. One must be aware of the corrosive and dangerous of the electrolyte in the capacitor also. Next point is, ensure proper voltage and kVA rating of the capacitor being commissioned or replaced. Now we are going to discuss next electrical equipment, that is generator. So as you know, generator is what? Generator means which generate the electrical energy. So in electricity generation, a generator is a device that converts mechanical power into electrical power for use in external circuit. Source of mechanical energy include steam turbine, gas turbine, water turbine, internal combustion engine, wind turbine and even hand cranks. The first electromagnetic generator, the Faraday disc, was invented in 1831 by British scientist Michael Faraday. So generator provide nearly all of the power for electric power grid. Real diagram of electrical power here you can see in the diagram. So following are the precautions that should be done while testing generator. So first point is, while entering generator, high voltage side, bus duct, etc., ensure that generator is at standstill and not on turning gear. Ensure primary drive is isolated. Second point is, ensure to disconnect space heater supply during work. If space heater is to be kept in service, this condition should be clearly highlighted. Space heater terminals should be adequately covered to prevent personnel coming in contact with the live terminals. Precautions against contact with the hot surface of space heater should also be taken. Third point is, ensure that generator is not taken on turning gear when testing in generator bus duct is in progress. Next point, ensure proper sound protection for the ear while working in vicinity of the running generator. While doing generator shaft voltage measurement, ensure proper safety. In case of hydrogen filled generator, follow the laid down procedure as hydrogen gas is highly explosive. Ensure decoupling of generator from primary mover wherever possible. The isolation valve to the turbine should be closed. Do not operate generator indoors. Generator should be placed outdoor in location where the exhaust gases cannot enter a home or a building. Good ventilation is the key to operating a generator safely. Next point, be sure the main circuit breaker is off and locked out prior to starting any generator. This will prevent intermittent energization of the power lines from the backfeed electrical energy from generator and help protect utility line worker from electrocution. Then next point that you have to take care, that is turn off generator and let them cool prior to refueling. Now we are going to discuss about the motor. So as name is indicating, motor is what? Motor is just opposite to the generator. So the reverse conversion of electrical energy into mechanical energy is done by an electrical motor. Motor and generator have many similarities. Motor have mainly two parts, that is stator and rotor, just like generator. Internal diagram of electrical motor of different part of motor, here you can see here the generator, motor, shaft, end ring, and all that you can see in the diagram. So basically motor is what? Motor is when electrical energy is converted into mechanical energy, that is called motor. Motor may be of the AC motor, may be the DC motor, or there are different type of motor like three-phase induction motor, single-phase induction motor, synchronous motor. Then if we are talking about the single-phase induction motor, this can again be classified as reluctance motor, hysteresis motor, capacitor start, capacitor run motor. So all these are the single-phase induction motor. So while testing motor, following safety precautions must be followed. First point is ensure that motor is at standstill and not on turning gear. Even after standstill, ensure the binding are discharged before testing. Second point, that you have to ensure that it should be decoupled from load. The motor should not drive the load and vice versa. The load should not rotate the motor during testing. Ensure to disconnect space heater supply during work. If a space heater is to be kept in service, the conditions should be clearly highlighted. Space heater terminals should be adequately covered to prevent personnel coming to contact to the live terminals. Next point that you have to take care, precautions against contact with hot surface of a space heater should also be taken. Ensure that motor is not taken on turning gear when testing. Ensure proper sound protection for the ears while working in vicinity of the running motors. While disconnecting motor, make sure to note down cable connection to prevent reverse rotation. One should ensure correct rotation of motor before coupling to load after overhaul or testing. Wrong direction of the rotation may cause severe damage. Now we are going to discuss about the test instrument. So following safety precautions should be adopted while using test instrument. First is ensure proper grounding of test instrument, especially while working on high voltage area. Second point is ensure proper grounding of equipment under test before test lead connections. Third point is ensure all grounds are removed after completion of all tests. Next point is do final maintenance IR measurement before charging the equipment. Next is use of dimmer state should be done, keeping in mind that both phase and neutral may have high voltage with respect to ground. Next point is dimmer state body should be earthed properly before it is used. Before HV 10 delta measurement at high voltage, do one reading at low voltage to ensure healthiness of the circuit. Keep all test instrument in cool place or shaded area for the protection against heat. Ensure field calibration of the instrument if required. Now we are going to discuss effect of electric current in the human body. It is very important to know how electric current can affect the working electrician or engineer while working on the electric line. So now we will see the effect of the current in the human body and what is the effect if what amount of current is flowing through the body. So if you are talking about if it is 1 milliampere current is flowing through the body, so you will feel faint tingle. If it current is around 5 milliampere, then it will be slight shock felt, no painful but disturbing. Average individual can let go. Strong involuntary reaction can lead to the other injuries. If you are talking about the human body of the woman and current is 6 to 25 milliampere, then she will feel painful shock, loss of the muscular current, If current is around 9 to 30 milliampere if the person is a male, then he will feel the freezing current or let go range. Individual cannot let go but can be thrown away from the circuit if extensor muscles are stimulated. If current is 50 to 150 milliampere, then what will be the effect? Now we have to see. So one will feel that if current is 50 to 150 milliampere, then extreme pain, severe muscular contraction, death is also possible. If current through the human body is nearly in the range 1000 to 4300 milliampere, then human will feel rhythmic pumping action of the heart cease, muscular contraction and nerve danger occur, and death may also be possible. If current is around 10,000 milliampere, then one will feel cardiac arrest, severe burns and death is also possible. Now we are going to discuss precautions need to be taken when working near high voltage line. So what precautions is needed when you are working at near high voltage? First is keep safe distance from high voltage lines, approximate 6 to 20 feet away depending on the strength of the line voltage. Second, use non-conductive wood or fiberglass ladders. Third, ensuring that the high voltage line has been de-energized before starting work in the vicinity of a high voltage line. Wear personal protective equipment such as rubber insulating gloves and insulating sleeves and industrial protective helmet. Educate workers on the safety procedure and requirement. Some medical device, that is pacemaker, can be affected by the electromagnetic field produced around high voltage. If you have one of these devices, you should inform to your project dealing officer. Next point that you have to take care when you are working in high voltage, equipment, that is cranes, a safe distance range from 10 feet to 42 feet depending on the strength of electrical source. Next point, always discharge the high voltage from component or terminal by using a safety probe. Next point is do not hold the test probe when circuit over 300 volt are tested. It is very important that you only work with any sort of electricity if you have completed an assessed training course run by an accredited training organization. Additional training would be required to work with high voltage electricity. Now we are going to discuss electrical shock and what are their effects. So first of all, we are going to discuss what is the electrical shock. Electrical shock occurs when the human body becomes part of path through which electrons can flow. The resulting effect on the body can be either direct or indirect. So if you are talking about the direct effect, so in case of direct, what may be happen? Injury or death can occur when electric current flows through the human body. Current of less than 30 milliampere can result in death also. If you are talking about the indirect, although the electric current through the human body may be well below the values required to cause noticeable injury, human reaction can result in falls from the ladder or scaffolds or movement into operating machinery. Such reaction can result in serious injury or death. Now we have to see what is the effect of electrical shock. So effect of electrical shock may be the burn. So burn can result when a person touches electrical wiring or equipment that is improperly used or maintained. Typically such burn injuries occur on the hands. Then arc blast. Arc blast occurs from high amperage current arcing through air. The abnormal current is initiated by contact between two energized points. This contact can be caused by person who have an accident while working on energized component or by equipment failure due to fatigue or abuse. Temperature as high as 35,000 degree Fahrenheit have been recorded in arc blast research. The three primary hazards associated with arc blast. So one by one we will discuss. So first is thermal radiation. In most cases, the radiated thermal energy is only part of the total energy available from the arc. Numerous factors including skin color, area of skin exposed, type of clothing have an effect on degree of injury. Proper clothing, work distance and overcurrent protection can improve the chance of curable burn. Second is pressure wave. A, a high energy arcing fault can produce a considerable pressure wave. Research has shown that a person 2 feet away from a 25 kiloampere arc board experiences a force of approximately 480 pounds on the front of their body. In addition, such pressure wave can cause serious ear damage and memory loss due to mild concussions. In some instances, pressure wave may propel the victim away from the arc blast, reducing the exposure to the thermal energy. However, such rapid movement could cause serious physical injury also. Third is projectiles. The pressure wave can propel relatively large object over a considerable distance. In some cases, the pressure wave has sufficient to force to snap the head of 3/8-inch steel bolts and knock over ordinary construction walls. The high energy arc also cause many of the copper and the aluminum component in electrical equipment to become molten. These droplets of the molten metal can propel great distance by the pressure wave. Although these droplets cool rapidly, they can still be above temperature capable of causing serious burn or igniting ordinary clothing or distance of 10 feet or more. In many cases, the burning effect is much worse than injury from shrapnel effect of the droplet. Next is explosions. Explosion occur when electricity provides a source of ignition from an explosive mixture in the atmosphere. Ignition can be due to overheated conductor or equipment or normal arcing, that is sparking at switch contact. OSHA standard, the National Electrical Code and related safety standard have precise requirement for electrical system and equipment when applied in such areas. Heat is developed in electrical conductor by the flow of electric current and it is equal to I square R. The heat thus released elevates the temperature of the conductor material. A typical use of this formula explains a common electrical hazard. If there is a bad connection resulting in a resistance of 2 ohm and current of 10 ampere flows through the resistance, the rate of heat produced would be, it can be calculated as I already told you that heat is equal to W is equal to I square R. So current here is a 10 ampere, so just the square of 10 is 100 and resistance is 2 ohm. So 100 multiplied by 2, so it comes 200 watt. So heat produced is equal to 200 watt. Now if it is multiplied by the time, then you will be able to calculate how much heat is being generated. If we have ever touched an energized 200 watt light bulb, we will realize that this is a lot of heat to be conducted in the confined space. Situations similar to this can contribute to electrical fire. Now we are going to discuss effect of electricity on human body. The effect of electrical shock on the human body depend on several factors. The major factors are current and voltage, second is resistance, third is path through the body, and fourth one is duration of the shock. The muscular structure of the body is also a factor in that people having less muscular and more fat typically show similar effect at lesser current value. So first effect that we are going to discuss, the effect of current and voltage. Although high voltage often produce massive destruction of tissues at contact location, it is generally believed that the detrimental effect of electrical shock are due to current actually flowing through the body. Even though Ohm's law apply, it is often difficult to correlate voltage with damage to the body because of large variation in the contact resistance usually present in accident. Although current greater than 10 milliampere are capable of producing painful to severe shock, current between 100 and 200 milliampere can be lethal. With increasing alternating current, the sensation of tingling give way to contraction of the muscles, muscular contraction and accompanying sensation of heat increase as the current is increased, sensation of pain develop and voluntary control of the muscles that lie in the current pathway becomes increasingly difficult. As current approaches to 15 milliampere, the victim cannot let go of the conductive surface being grasped. At this point, the individual is said to freeze to the circuit. This is frequently referred to as let go threshold. As current approaches 100 milliampere, ventricular fibrillation of the heart occurs. Ventricular fibrillation is defined as very rapid, uncoordinated contraction of the ventricles of the heart resulting in loss of synchronization between heartbeat and pulse beat. Once ventricular fibrillation occurs, it will continue and death will ensue within a few minutes. Use of a special device called a defibrillator is required to save the victim. Heavy current flow can result in severe burns and heart paralysis. If shock is of short duration, the heart stops during current passes and usually restart normally on current interruption, improving the victim chance for survival. Second effect that we are going to discuss, that is resistance. The resistance of a human skin varies from person to person and fluctuates between different times of the day. The NIO has stated under dry condition, the resistance offered by the human body may be as high as 100,000 ohm. Wet or broken skin may drop the body's resistance 1000 ohm, adding that high voltage electrical energy quickly breaks down human skin, reducing the human body's resistance to 500 ohm. Studies have shown that the electrical resistance of the human bodies varies with the amount of moisture on the skin, the pressure applied to the contact point and the contact area. The outer layer of skin, the epidermis, has very high resistance when dry. Wet condition, a cut or other break in the skin will drastically reduce the resistance. Shock severity increase with an increase in presence of contact. Also, the larger the contact area, the lower the resistance. Whatever precautions is offered by the skin, resistance decrease rapidly with increase in voltage. Higher voltage have the capability of breaking down the outer layer of skin, thereby reducing the resistance. Third point that we are going to discuss, path through the body. The path that current takes through the body affects the degree of the injury. A small current that passes from one extremely through the heart to the other extremity is capable of causing severe injury or electrocution. There have been many cases where an arm or leg with almost burned off when extremity came in contact with the electrical current and the current only flowed through the portion of the limb before it went out onto the other conductor without going through the trunk of the body. A large number of serious electrical accidents in industry involve current flow from hands to feet. Since such path involves both the heart and the lungs, result can be fatal. Fourth and last point is duration of the shock. This is very important point. The duration of the shock has great bearing on the final outcome. If shock is of short duration, it may only be a painful experience for the person. If the level of current flow reaches the approximate ventricular fibrillation threshold of 100 milliampere, shock duration of a few seconds could be fatal. This is not much current when you consider that a small light duty portable electric drill draws about 30 times as much. A relatively high current, a death is also possible if shock is of appreciable duration. However, if shock is of short duration and if heart has not been damaged, interruption of the current may be followed by the spontaneous resumption of its normal rhythmic contraction. So dear learner, in today's session we discuss safety tips when you are working on capacitor bank, generator, motor and test instrument. Then we discuss electrical shock and their effect, and after that we have also discussed effects of the electricity on the human body. Thank you very much.